Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Hello and welcome to podcast number 126 for the month of May 2025. And we'll begin as usual with the puzzle of the month.
Freddie returned a defective Bluetooth speaker to the shop and asked for his money back. By mistake, the shop assistant reversed the pounds and pence in the refund. The amount of pence was given as pounds and the pounds were given as pence. Freddie did not notice and put the money in his pocket. On his way home, he used £1.50 from the money in his pocket to buy a drink. When he got home, he counted the money left in his pocket and found he had exactly twice as much as the cost of the speaker. What was the cost of the speaker?
That's the Transum puzzle for this month. The challenge is set. Have a think. Make a plan. You have 1 month to figure it out. Send in your solution as soon as you can.
So yes, please get in touch if you solve the puzzle. podcast@transum.org. That'll do nicely. And while you think about that, here are some of the key resources added to the Transum website during the last month. Pythagoras with surds. This new 3-level exercise was suggested by subscriber Sharon, way over there in Beijing. As the title suggests, each question requires Pythagoras' theorem to find a solution which must be written as a simplified surd.
The text version of this podcast can be found at transum.org/newsletter.
Okay, 2 measures is a new 3-level exercise. It takes 2 rulers to measure a pencil. And that's only the first question of level 1. By the time you get to level 3, you'll be wondering how those elementary school children in China figured out the height of their table with the help of a cat and a tortoise. The links to all the things I'm rabbiting on about here can be found in the newsletter, transum.org/newsletter. So do please go and have a look and see if they would be useful for the students that you teach. Problems leading to quadratics is a brand new exercise designed for those who have already mastered the methods of solving quadratic equations. There are a total of 30 questions presented in a 3-level self-marking exercise. Now there is a theme connecting all of the questions as they are taken from an 1885 textbook, though the English has been updated for a present-day reader. The contexts add interest to the questions, and by the time you reach level 3, you're wondering how those 19th century learners managed, because they get very hard. Okay, I've started collecting hidden gems. That's my name for some of the activities on the website that you may not have come across before. They are activities that do not necessarily fit into particular topics, but I feel they are very worthwhile nonetheless. They are all related to some mathematical concept, and each one of them has worked well with my students at some point in the past. So, click on the links in the newsletter, transum.org/newsletter, to have a look at some of those hidden gems you may not have used before. The recurring decimals exercise now has a 3rd level. Inspired by the comment from subscriber Anne, and you can see that comment underneath the exercises, level 3 invites learners to distinguish between terminating and recurring decimal equivalents by considering the prime factors of the denominators of the fractions reduced to their lowest terms. And believe me, it's actually much easier than that last sentence suggests. The month of May usually signals the beginning of exam season for many. So in the newsletter, there is a link to the revision resources you may like to pass on. In the Northern Hemisphere, the weather, as I'm hearing today, is expected to improve relative to its previous performance, and you may find it possible to do some outdoor maths. Again, there is a link in the newsletter to my outdoor maths ideas. The 1st of May has a calendar-related starter called May Day, and the 4th of May, for those of a certain age, is, of course, Star Wars Day. May the 4th be with you. As you may remember, I enjoy listening to podcasts, and in a recent episode of Tim Harford's Cautionary Tales podcast, an intriguing conversation with Freakonomics co-author Stephen Levitt touched on the concept of maths appreciation courses. So Tim asked Stephen, what do you think we get wrong in the way young people are taught to engage with numbers?
So I think what we do up through about the age of 12 or 13 is not that bad. I think knowing how to add and subtract and divide and do fractions and things like that is just a basic skill in life that you need, and everyone should have that. And look, I don't think we do it in the most efficient way, but at least we have our eye on the prize up through about the age of 13. High school math, on the other hand, I think is a complete horror show, because we ask children to do a whole bunch of math, which is complicated, based on doing computations that nobody does anymore. So one of the things that I watch all of my high school kids do is try to learn how to compute the minimums and maximums, or the zeros of polynomials. And that was something that they did in Hidden Figures, that movie about getting people to the moon, because we didn't have good computers. And so people had to do that. But since computers came in, there's not a person on the planet who's had to do that manually other than, a high school student. Yeah. And we try to teach kids how to do proofs. Again, great. I think knowing how to prove things is wonderful. But we make them prove all sorts of things about triangles that who cares about? Back in ancient Greece, it was important to know things about triangles. Now it really isn't. What do people actually use in their daily life? They add and subtract. They do simple arithmetic, and that's good because they've usually learned that. And then they analyze data. They use spreadsheets that have to make sense of complicated relationships. And we do almost none of the teaching of that in high school. And so data science, you might call it, data analytics, that those are the skills that people need. And I believe we should teach people the things that they will use. Many of the hardcore mathematicians get upset. They say, we're not teaching deep math. But I would tell you there's very deep math in data science, and a lot of artistry and a lot of judgment. And another thing that we've been doing at my Risk Center is we ended up launching something called Data Science for Everyone, which has become the leading think tank advocacy group that's trying to change the way we teach math to incorporate data science in the United States. And it's been really, really quite successful.
I'm sure you know Steve Strogatz has this idea that colleges should teach math appreciation. We have art classes where you teach people to draw. You have art appreciation where you teach people the history, and you get people to look at pretty pictures and discuss like why they're such stunning works of art. And he suggested for some students, okay, fine, they're not going to calculate a lot of stuff. They're not going to be high-powered mathematicians or statisticians, but they could still have an appreciation of how math works, how data works. I guess Freakonomics should be on the course, right? It's an example of data appreciation. It doesn't really tell you the details of how your detective work was done, but it gives you a sense of the kind of things you were doing and the kind of things that you could do if you had control of the data.
Steve Strogatz and I have talked a lot about that, and actually worked with the state of Utah in the United States to try to implement some of those ideas. And we're just getting going. We'll see how that works. The discoveries, the process of the history of math, I think is actually fascinating once you get into it.
Yeah.
But the real power of this idea of appreciation is with young people, because so many 12 and 13-year-olds are right at the point where they're deciding, I'm not a math person. That's not for me. And then they check out. And that's because they don't understand why they're doing this complex math, and which makes sense because I don't really understand why they're doing that complex math. But on the other hand, if you instead focused with young people and saying, hey, here's what's amazing about math. here's how math is useful. Here's how math is a form of storytelling, or here's how math is the language of the universe. I mean, my own high school kids, they just thought, well, the teacher told me I do this, and this is the answer, and so I do that. But they didn't really understand it was true, that if you went to a different galaxy, it would also be true. And so I think the idea, the most powerful part of the appreciation idea, is you take people who are still trying to figure out who they are. They don't know who they are, and they're making these choices. And if they say, whoa, maybe math is fun, then they won't close off the path to eventually maybe saying that math could be a part of a career for them. They don't have to be afraid of science. And so that's where I think the idea has its real legs.
Four days ago, 27th of April, just before 12:16 lunchtime, it was time for my annual check that the sun is obeying the rules. So the sun is directly overhead where I live at that time each year. So there are no shadows from the 3 cans that I piled up to make a sort of a tall vertical structure, 3 tin cans. And I'll call that my three can test. And then I took a photograph of it, and I've put the photograph in the newsletter, and it shows that there's absolutely no shadow at all. Yes, that was Bangkok's shadowless day, or zero shadow day, as it's sometimes called. But why doesn't it occur at exactly noon? So I consulted my trusty AI friend, and of course it reminded me that there is of course a longitude correction because of where Bangkok sits in the time zone. So because it lies 4.38 degrees west of the zone meridian, so solar noon comes 17 minutes 32 seconds later than 12 o'clock. Okay, well, yeah, I could have thought of that if I'd have really considered the issue. But then it came up with this. Then there's the equation of time. What? What on earth is that? On the 27th of April, the sun runs about 2 minutes 20 seconds slow relative to mean time. What? Really don't know what that is about. So it gives me a little calculation. The 12, that's noon, plus the 17 minutes 32 seconds, minus 2 minutes 20 seconds, gives the answer 12, 15 and 12 seconds. And that's when the solar noon for Bangkok occurs. Ha! Of course, no shadows are also attributed to vampires, witches and Peter Pan, but 3 cool drinks in my cans are far preferable. Finally, the answer to last month's puzzle, which was...
I paid £3.60 for the mini Easter eggs I bought from the corner shop. The shop owner added 2 extra eggs because the best before date was rapidly approaching. That brought the total cost down by 30p per dozen compared to the original price. How many eggs did I buy?
The answer is 16. And if you want to see some solution methods, have a look at transom.org/newsletter, where you can see some different ways of solving that puzzle. The puzzle was adapted from a similar puzzle posted on the James Madison University website. That's where I got the idea from. And the first 5 people to solve the puzzle were Kevin, Chris, Rick, Marla and Esther. So thanks to everyone who took part. Good luck with this month's puzzle. So that's all for now. Oh, apart from to say, why doesn't the world of whole numbers trust primes? Because they make up everything.
Thank you for downloading and listening to the Transom podcast. You can find the website at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.